Welcome to the ET335 practice final number 1. Okay, let's figure out the modulus and count of this. So in order for this to work, we're going to need to do a reset. So this guy's going to have to be a 0. In order for that to be a 0, this needs to be a 1. These two here need to be zeros, and these two need to be 1s. So this guy's going to be a 1. This is going to be a 1, and this one's going to be a 0. So we need to reverse of 1, 1, 0 is going to be 4, 2, 1, which is 6. Good. Okay, so what we're going to do is this needs to be a clock pulse. And so what number? So in order for this to be a 0, and this to be a 0, this is going to be a 1, which is going to give us our clock pulse. So we're going to have 1, 0, 0, 1, and we could, in this case, we could assume either 1 is our least significant digit, so it's going to be a 9. Okay, let's design a decoder circuit. So it doesn't allow us to doesn't limit us on the gates. Let's just go ahead and build it with basic gates. Let's do an AND. And let's use an OR. And we could change those here in a second. And let's go ahead, and since this is syncing, let's go ahead and use a NAND. Okay, so this is going to be a 0. In order for that to be a 0, we need a 1. 1. Since this is a 1, we could come out of here. And this is going to be a 0. And this is a 0, so I think a NOR would be a good choice. 0, 0 equals 1, and that'll work. And here's our CAD drawing of another possible circuit. There's many ways we could do this. We want to convert this Boolean equation to a circuit. So the first one is going to be a NOR gate. A and B. We need a bubble for the NOR. The other one's going to be a NOR gate. With C and D. And then we're going to go into what appears to be another NOR gate. Okay, so we got this, this, and this. And our last one is going to be an AND gate. Excuse me, a NAND gate because of the bar over the top. Good. Okay, this is a CAD example of our answer. Okay, let's figure out what turns this transistor on in order to make the LED light. So the LED is syncing because we're providing a voltage. So we need a 0 here. So we need a path to ground. So our Q1 is going to be off, and our Q2 is going to be on. And that'll make our LED flash, or excuse me, light. Here we have waveforms into our JK latch with a preset and clear, and the preset and clear are asynchronous, so they're going to be in charge. So this guy's a preset, so he is going to go high right in here, and he won't change until we get a clock input. And here we're going to have a clear, so we're going to go clear here. Alright, and this is a negative edge, so we're going to be looking at it at this time. Alrighty, so we're starting high and we're do the clock, and it is going to toggle. And then we're going to shoot back because of our preset. And we're going to go to the next one, which is, it will be a low, low, which is no change. Then we're going to go to the next one. It's going to be a toggle, high, high. Then we're going to go over to the next clock, and it is going to be a J, 1, 0, so it's going to go to set, immediately go to reset, and the next clock is going to be a 1, 1, so we're going to toggle. Good. And here's our CAD layout of our waveform of our JK flip-flop.